Today I'm going to study Threepp, which is a library that I found that is supposed to convert Three.js to C++. So I'm gonna study this and try to implement on the stuff that I'm working on. I think I'm gonna talk about first. I think I understand now how it works, but I don't like it that much, the way that this works on OpenGL, the buffers, the way you have to set up. But it's more clear in my mind now. Except this EBO, I still don't understand the EBO very well because I didn't look too much into it. But the array buffer and the VBO, I think I understand. So I'm gonna explain this first. And like the reason why I don't like is because you have to. It feels like you have to remember the order that you call everything, and like because it depends on the sequence that you order. Because when you set up the buffer, the sequence matters. So I have to remember that it feels kind of loose. I can't really explain very well why I don't like it, but I think that they have to do it this way because probably the memory is limited in the GPU. And I think that the OpenGL sets up the functions. It's like an interface with the GPU. So the way that it works is that this function here, this function calls, they are actually these ones. They are supposed to tell OpenGL how to manage the array of data you're passing to it. So it's a lot more clear on my mind now. So the first argument is the location of the variable on the shader. So you're pretty much telling OpenGL how it should take the values you pass into the array and replace the variable names inside of the shader with that value. So the first one is the location of the variable that is going to be replaced by the value that you get. The next one, I think, is the size, is the amount of variables that the amount of values that the variable is supposed to have. So like in this example is 3 because it's a vector 3 here. So you're telling that the variable is going to use 3 values on the array. And then this one here is how many steps it has to go in order to get the next value in the array. And it always has to be the same steps. So I assume that, I assume that it has to be this way because they do it this way. So if you put like 5 times the size of float here, you can't have a situation where the next value of the variable inside of the array is going to be 6 steps ahead. It always has to have the same stride. So, and I guess that it makes sense because it makes it easier to set up because you think about one chunk of values you want to send to the buffer. And then after that, you're just going to repeat like the same pattern. Because the main thing that is going to change between the way that you decide to send data is going to be what the data is for. So in this example here, for example, the 3 first values are related to the position and the next 2 are for the texture. And then it's always going to be that way until the end of the array. Or you can do on the other example where it's just position. So, and when you don't have this like interval between things, they say that it's tightly packed. So what that means is that in this example here, the value of one position is right next to the value of the previous one. And there isn't anything in between. So in this case, you don't need to put this argument here that specifies when it's going to be because OpenGL is going to figure that out. But if you do have a situation where you have 2 different types of values that are going to be used to 2 different variables, then you have to specify because then OpenGL is going to know after I consume these 3 values from the array, I have to jump this certain amount here, this stride, in order to find the next value in the array that is supposed to be from the data you're sending. So like the way to think about it is that these functions are used to set up the buffer, and then the other functions that you're going to do inside of the render loop is going to be to consume the array, the buffers you set. So it's kind of like a bridge. In the beginning, you're setting up the data that is going to be inside of the buffer, which is just a place in memory that the GPU is going to use. And then inside of the render loop, you're telling OpenGL how to get the data that is inside of the existing buffer, so that it is able to go through the whole pipeline and then draw stuff on the screen. So yeah, but this is the thing that I mean that I don't like, is that if I don't know, it feels like it is kind of, so that's the thing that I'm struggling to think about. But probably it's just gonna be annoying in the beginning. Then after you set the first class, then you don't have to think about it anymore, because then obviously everything's gonna be based on the abstraction you created. So the main difference between the other confusing thing is the VBO and VAO. VBO is vertex buffer object, and VAO is vertex array object. And the main difference between them is just the way to think about it is just VAO is a wrapper for the VBO. So the main thing that the vertex array object does is to store the state of the VBO, which is the vertex buffer object. Because if you don't do that, then you have to do the setup here every time that you want to do something with the buffer. But if you use the VAO, then the state gets stored on the VAO, and then it reduces the amount of functions you have to call, because you don't have to do all the setup here. All the setup is stored inside of the VAO. So it's just like creating an abstraction, so you don't have to. The good way, like a good way to think about it is as if you create a function, then you encapsulate all the thing on the function. The name of the function is VAO, and then from that point you just use VAO, just call VAO instead of calling all these methods here. So that's the way that I'm thinking about it now. So I think that is correct, but obviously I'm not 100% sure because I don't have a lot of experience with this. So, and the EBO, as far as I understand now, is that a lot of the points you're drawing, they're gonna have the same coordinates because they interlap. So the X, Y, and Z, some of the points are gonna have the same X or same Y and so on. So in order to not repeat all this data and to optimize the amount of data you're sending, so you don't repeat yourself, you create these indices here that tell OpenGL at what point there are unique data that it has to be, or that the data is repeated or something like that. And then you use this EBO, so it pretty much allows you to reduce the amount of data you're sending because you have these indices that specify where the data is unique or repeated. So, but this is kind of like the thing that I don't like about this is that, and I don't know if how to solve this or if people have ways to, I assume obviously they have, but like what is the best way to create the abstraction that is gonna allow me to solve this? Because you can imagine that it's kind of hard to, like if you're gonna draw a very complex geometry, you're gonna have to think about all the points, and then you have to think about how you're gonna structure the array of floats so that the points are correct. And then you're gonna have to think about all the indices that are repeated, that the data is repeated. And then gonna have to create this one, and then remember all that and specify on here. So it seems like there's a lot of points where there can be a mistake, which I don't like very much. So I assume that obviously there's a way to create an abstraction that allows you to not have to think about this stuff. And this is the reason why I'm gonna try my best to use the functions on the library instead of having to think about all this stuff here. So if I can, I'm just gonna try to use the functions that of the Threepp, or if it doesn't work for my case, then I'm gonna try to use the raylib functions, so I don't have to think about this part here. And then the last case is if both of them don't work, then I'm gonna have to think about, I'm gonna use Three.js, and then I'm just gonna try to get the functions from Three.js where they create the points, and then just create the abstractions myself. But the problem with that is that it's gonna be very hard because I'm gonna have to think about what is the best way to create the classes and all this other stuff. And then there's a bunch of points of failures, and then a bunch of points where there's gonna be trade-offs as well of which thing is the best thing to do probably. So I'll open another project with this. So I'm gonna close this window here, and I'm gonna focus on the other project now. The other one I just created to learn a little bit more about how OpenGL works. Here I think I'm gonna close all these other files as well. Put some music for myself. And I was studying these shaders as well. I'm probably gonna study these functions at some point as well. So, but probably it's better to study this project already. I'm not. I'm gonna try to not get the whole project and just get the. I think I'm gonna close all these files here. I'm kind of as hesitant of closing all the files because it's kind of annoying to find them on the project later, but I think I have to. I'm just gonna close everything. So I'm gonna try to only get the functions or the classes that create the geometry, because this library is not on the Raylib. It doesn't use the same abstraction, so it uses GLFW, I think, and OpenGL, which Raylib also uses, but it doesn't use the abstractions from Raylib. So I'm gonna try to get only the classes that I'm gonna use. I should probably make a list of the classes as well. I think I have done this here. I'm using sphere geometry, then some other line meshes and other geometry to create the arrow. So pretty sure I wrote down here somewhere. Oh, this is another thing that is kind of confusing to understand, which is the Quaternion. So as far as I understand, Quaternion is just a three-dimensional, it's a four-dimensional. There's one real number and there's three complex numbers. And then the way that it works, the rotation, is that you're gonna grab one of these Quaternions, which is this vector of four numbers, three complex and then one real. And then you're gonna multiply that by the vector you wanna translate, you wanna rotate. And then after you do that, you multiply by another Quaternion that makes the full translation or full rotation. And the way that conceptually I think it works is that you have the vector on the real plane, let's say. And the reason why you do this two multiplications is because one of them brings the vector on the real plane to the complex plane, and the other one brings it back to the real plane. So, but it's very hard to think about it, obviously, because it's on like more dimensions than space-time. And I think that you have to divide the angle by 2 for the multiplication, because you multiply it twice. So one part of the multiplication does the rotation halfway, and the other one does the rotation all the way around. And it seems like the Quaternion is more effective. But so I hope that the libraries have the functions should do that. If they don't, then I'm gonna have to either find the functions or think about this a lot more to do it. And the reason why I think that it works this way is because the complex plane is I'm not really sure like which way it goes. I think that it goes from the complex plane to space-time. So space-time is a projection of the complex plane. That's how I think about it. So this is the reason why it works, because they are reflections of each other. And this is the stuff that I was thinking about, the perspective projection, that I kind of realized when I was studying this stuff, is that, at least for me now, it seems that the perspective projection is the Maslow hierarchy of needs is a reflection of the perspective projection, and they are mirrors of each other. So the inside of existence, the introspection, exists on the complex plane, which is the imagination. And then reality exists on the space-time, which is the field of view. And the bridge between them is the third eye, I think. And that's the reason why DMT allows you to go to other, like, quote-unquote, dimensions, because they're reflections of each other. Like the inside is the outside. And the frequency of the reflection of light that creates geometry is going to be like the projection of the complex plane. But they're both connected with each other. I don't think that one is dependent on the other. I think they simultaneously create the illusion of past and future, which is the cause and effect relationships. And then the Maslow hierarchy of needs is just the biochemistry of the body that generates a gravitational force and then creates the illusion of geometry, which is the illusion of space-time, of distance and time. So pretty like interesting stuff to think about. Yeah, so this is the list pretty much of the stuff that I need from 3JS. I don't know if it's worth it to think about like how to optimize the shader, because another thing that I was thinking about, and this is another thing that I realized yesterday as I was explaining this stuff of how the graphics pipeline works, is that the best way to think about the matrices is that they hold the state. So a matrix is just a state holder for the positions of whatever you want to render. And another interesting thing is that this relationship between different coordinate systems, and that made me think about spacetime as well, because spacetime is just a synchronicity of a coordinate system. So like the common reference frame of a network creates the illusion of spacetime, because that's what defines spacetime. It's just the synchronicity of a network. That's so all the networks use the same coordinate system, which is always relative, but because they use the same, they have like a shared meaning between them, which is the world view. And then what I was thinking about is that there is this concept that also I watched the video from this guy here. So I really liked one of his videos that I was trying to understand, I think, rasterization. And then I got the YouTube. I actually searched for it, and then it was recommended. So I started looking into the whole playlist. But it's not only this guy is. This is the video that I'm gonna watch now. But there is also something on the WebGL that they talk about, like an efficient way to create a scene is to make one matrix dependent on the other ones. So you create a tree of matrices, obviously, because then you create a cause and effect relationship between things. And it makes perfect sense. Like, because if you want things to be connected, then obviously it makes sense that once you change the matrix of one of those things, you have to change the matrix of other ones because they are connected. And I think that's what gravity is, and the cause and effect relationship between things is just the way in which the matrices are going to be created, which is just a reflection of the how light gets reflected on things. So pretty much the way that I think now is just that reality is a projection is a reflection, and they're both connected. The inside is connected with the outside. It's just a mirror. Yeah. So this is the. I'm not really sure if this is the article. I think it's the Sing. There is one that they talk about simulation of Earth and the sun or something like that. I forgot which one it is. Also, the other thing that I have to understand more is frame buffers. So frame buffers, it's pretty much a buffer that allows you to put all the other buffers. So in the same way that the vertex array object is used to store the state of the vertex buffer object, the frame buffer is used to store the state of the whole frame. But I don't know the nuances of it very well and how to use it. But I've seen on Raylib source code that they use frame buffers sometimes. I think it's this one. Yeah, this is the article that talks about the thing. But I'm not really sure like what to make of it, because it's kind of, I don't know. It's hard to think about like what exactly does it mean for one matrix to be dependent on the other one. And I think that's the thing. It always depends on the perspective, on the matrix that is responsible for the perspective of the awareness that reflects on itself, because of the singularity point that is the bridge between the inside and the outside, which is, I believe, is the third eye. And so like the camera matrix, for example, is the thing that is going to create the illusion of the scene. So the spectrum of causality, the cause and effect relationships between things in the visualization is always going to be relative through the reference frame you use to create the synchronicity of all of them, which is the camera. So that's always relative. So, and this is, I think, that's the collapse of the duality that creates the paradox, which is that reality both is perception, but there's also something real, and that's the world coordinates. So the camera is the thing that creates the spectrum of causality, which is always relative. That's why perception is always, perception is reality. But at the same time, there is a world coordinate, which is the space-time, which is also relative, but it is like the shared meaning of the network of how all the different cameras are creating the illusion of cause and effect between things. Because whenever the network has the shared common understanding of what that is, that's what defines the structure of space-time, I think. Just the synchronicity of a network. Hey, man. What's up? Let me go over the code. Maybe I should go over the GitHub repo. What's the library supported? Blah, blah, blah. Oh, there's also this group that I forgot that I'm using. So I'm using group geometry to connect the arrow and the edge, the arrow and the sphere. No, it's not the arrow in the sphere, the label in the sphere. Because obviously when I move one of them, I have to move the other one. So I have to see how this is done as well. So I think that I'm gonna start by the geometry probably. Not really sure if they're coupled with other stuff. So there is an edges geometry. Probably cone is the one that I was using. I think that the tube geometry is the one that I was using to create the arrow. It's just a tube, and then the size of the circumference, I think, creates the pointing of the arrow, I think. Sphere geometry. No, shape geometry. Toros. So the reason I was talking about all these matrices and the scene is because I thought about, like, one way, for example, to do an optimization that I think about is that you can have a giant matrix, or you can have a function that connects all the matrices and then updates the entire graph at the same time. Because all that the objects are just the model matrices of them. So the model matrix is going to hold the state of the objects. So, but then I think it doesn't matter that much, because you're still going to have to think about the graph. Because obviously the positions are going to be determined by the physics engine. So you still need to go over the graph and calculate all the positions, but maybe it can be more effective. Like if you have a shader that multiplies all the model matrices at the same time. But I don't know if that works. Because the thing that is confusing to think about the shaders is that usually when you think about the shader, you're thinking about the resulting geometry that you're gonna have. But the shader works point by point. So I think and this is the thing that was kind of confusing to me yesterday as I was planning this stuff as well, is that like, how is it possible that when you multiply the camera matrix by the model matrix, we're gonna have the position of the final visualization is gonna be what's gonna show on the screen is gonna be parsed through the lens of the camera, because that's what effectively is doing that. Like you have the matrix that holds the state of the camera. And because you multiply everything by the matrix, the final position that is shown is through the perspective of the camera. But how is that possible? Because what's happening on the actual math is you're just multiplying the values of x and y and z of the camera with the values of the models. And because you're using the same matrix for the camera for all the positions, then it turns out that the final visualization that's going to show on the screen is going to be through the lens of the camera. So the thing that is confusing to understand is like, why does that happen? Like, what happens if you also not only multiply by the camera, but you multiply by another object, random object. So you have two model matrix on the shader, and you also multiply all the points through that model as well. Is that gonna mean that you're gonna have two different cameras? And then like what is gonna be the end result of the visualization of that? That's the thing that was kind of confusing to me. And I'm not really sure if I know this answer. Because I think that the road is always the same, the world coordinates. So it's not like you're changing where the objects are on the scene. You're just changing what's going to be shown on the final normalized bias coordinates, which is going to be the screen space, because you're multiplying everything by the camera matrix, which is going to change the position of x and y of the final visualization to represent where the relative position of the camera is at. So I think that when you have this situation where, for example, you have two different cameras and you multiply everything by the same matrices, what you're going to have is on the final visualization is going to be the shared coordinates of both of the cameras. So whatever is going to show on the screen is going to be what's shared between the cameras. And that's an interesting, because that is, in a way, that is what's happening as well. Because you're always multiplying by another model. So I think that's what the meaning of this thing is. Like whatever is common between shaders is the shared visualization that is going to be shown. But I don't know if that makes it so that if you have a shader that multiplies all the models simultaneously, instead of multiplying one by the camera, you would see the final coordinates you would see would be as if all the models are acting as cameras, and whatever is shared between them on the perspective projection of all of them is going to be shown on the screen. So I'm not really sure about this. So you can think about it like a weighted distribution of the points that you're sending as data. So if you have a shader that, maybe I should open the other stuff. Sure. The thing is that I'm concerned of deviating too much from the stuff that I'm doing, but I do think that these things are very interesting to think about. So for example here, like if instead of having one model, let's say I'm gonna have a graph. This is another problem because I don't know how many nodes I'm gonna have on the graph, so there wouldn't be a way for me to have like an arbitrary amount. Maybe there is actually on the shader code. Like you can create a function that does a loop and then it creates a model variable based on the loop, but it's probably very complicated to do that. But what I'm talking about is that if I have two different, let's say this represents the state of one point, and I wanna multiply by another point, and I wanna do this obviously for all of them. What would happen? Like, what would be the final GL position that shows there? Because the GL position is the thing that is gonna show on the screen, I think, on the final thing. And I think the reason why the GL position shows the perspective from the camera is because you're always multiplying everything by the view, which is the camera matrix. So the question would be, if you multiply not only by one model, but by all the models, then what would be shown on the screen? What would be the part of the world coordinates that you see? And I think that now, at least for now, I'm not 100% sure, but I think what would be shown is the the weighted average of all the points. So it's as if all the points are acting as cameras, and you would be probably like the perspective, you would be the weighted average of all the data seen through the perspective of the projection matrix. So it's as if every point on the scene is creating its own projection, and then the shared projection of all of them would show on the screen. And that's probably what space-time is, I think. Because it's just a shared meaning of all the data that exists. So it's kind of paradoxical in a way, because obviously you can never know. But maybe this would be one way to optimize. But I think that it wouldn't work. That's the problem. Because I was thinking about doing this to optimize how fast the graph is rendered, because obviously if I can compute all the positions simultaneously for all the points, then like you don't need to pass a bunch, to do the same calculation a bunch of times. You just do one big matrix multiplication. Maybe it is possible. Maybe if you change the model, but I don't think it would work, because when you multiply directly, it makes the point one point based on the other. It makes them connected to each other. That's the thing. So it's pretty much the same pattern here. So it's inheriting from the buffer geometry. So the way that Three.js works, maybe I should do something on the SkyDraw, because now it's very clear on my mind how everything works on Three.js. I mean, maybe it's not worth it to do a graph. Maybe it is if I put everything. Because there's two separate graphs, and they are both trees. So the way that it works is that you have the base, which is going to be an abstract syntax abstract syntax class. I think it is abstract syntax class. And I think it's a very common pattern I've seen in Python a lot as well. In Python, there is a class called ABC, I think, that they always use. So the way that it works is you create one class that is going to serve as a template for all the other classes. And then inside of this class that is a template, you create something that is called a virtual function. And the virtual function is just like a specification or a recommendation for all the other classes that are going to inherit that class, so that all of them have like the same structure. So that's how, as far as I know, Three.js does things. So there's both the tree for the buffer, for the geometry side, and the tree for the mesh. But I'm not really, I don't know, because there is it's not actually the mesh, it's the material. So one tree is the geometry, the other tree is the material, and then there's another class that is called the mesh, which is gonna grab the geometry and the material and is gonna create the program. So everything I think inherits from buffer geometry on the geometry side, and the on material side I don't remember very well. And then these classes are used to like the child classes are used to specify the specifics of the data that you have to send for the buffer to create a geometry, and then the buffer geometry is gonna manage how the data is gonna be passed through the shader as variables to create the thing. And I don't remember really well how. I think it's in the beginning, but there is a function here that is responsible for selecting what kind of shader is going to be used for the visualization. But this part's kind of still confusing to me. But there is one of them here that I found last time, I think. I think it's this one. Yeah, this. So this class pretty much looks like it is a function. So this one is the class. But it selects based on this object here that maps the shaders with the names, and then there's another file. There's two different files here that they store all the shaders. There's two different folders where they have all these files and they store the shaders on JavaScript codes. It's just a string. I don't know how the import works though, because all of them import something. Like they import inside of the shader. It's not very clear exactly how they use it, like how they select and then they use that shader. Because the way that it works is that you set the shader code, which is going to be a string, and it's going to be on GL, SL language. And then on the JavaScript part, you get the variables from the shader with the buffer. And then you set the variables through the buffers. So I assume that's probably what they're doing here. And then obviously, like that is handled by this class, I think. It's either handled by this or the final mesh that connects them both. I think this one just stores the states of the variables. And then have this count here, which is gonna determine how many times you have to read from the data that you're sending to the buffer to draw the whatever geometry you have. So it's very clear on my mind how it works on the concept level, but not the nuances very well. This creates shared pointer to edge geometry. One thing that I was thinking about searching for as well that I just thought about, like if I have to create the shaders myself, probably what I'm gonna do is just create a VBO and VAO inside of the function, and then I'm gonna have to return them because they're both integers. So the way that it works is that you create them like from the examples I think is undefined, so you don't specify any values to them. You just create, which is going to be a random place in memory, and then once you pass to the functions from the OpenGL functions, that integer, OpenGL is going to make them equal to something. So it's going to map that variable to an integer, and the integer is going to represent how which location you have to go to access the value, to access that buffer. So obviously I need to keep track of that for the other functions, but maybe I will do that on the I can create another class that is a shader class. And this is another thing that's kind of annoying about Raylib because they took the shader name. So I'd have to create another name for the class. And then I've seen some tutorials as well that they create a class, a shader class. So I would probably store the values of VBO and VAO inside of the class as private variables, and then I'll create all the functions. Like pretty much just pass all the functionality from the examples inside of functions from the class. I think it's not that hard, but there might be a bunch of mistakes that I make on the nuances of like C++ because I don't have a lot of experience. So if possible, I want to avoid that. So I wonder if they have examples. Yeah, here. Well, first I'm gonna look at the. I'm gonna look at the geometries, then I'll look for study the examples, just see how they use. I assume that here, I don't think this is a constructor, it's just a function. So I assume that the way that you do it, you just create a class and then you call this thing here, but then the question is obviously what do you pass here? I'm not really sure. I don't think that's how it works on 3JS. I don't know if there's an edge geometry here though. So maybe I should start by the sphere. Let me see this one as well. This is kind of another thing that might be annoying. Just the event dispatcher. There's another big question that I have is what is the best way to handle the events? Because obviously, like, I'm only gonna focus on that once I have the simulation, and then once it gets time to create the GUI elements that are gonna, and then I'm gonna have to figure out how to connect them both. So obviously, I'm thinking about connecting them through the through the Raylib functions. That's have the keyboards and stuff like that. So, but then the question is obviously what's the best way to connect them? It generates a random number here. It's just a function that generates a constructor that generates a random number for the class. So guys, it's kind of like creating a hash to keep track of what class is. There are some. I don't remember. I remember that I saw this in a couple of different places that you use random number generators to do stuff with the visualization. But I think there's like a few ways to use them, and I don't remember really well what's the point. I think it has to do with the position of everything and then the time of the visualization. But for this one here, I don't really understand very well like why they create this random. It's kind of like a hash that keeps track of the function, but why? So it also has the draw range, bounding box on this here. Hmm. I should probably try to run the example that they share now. Like the problem is I'm not gonna use. I'm gonna have to change these classes so that they work with Raylib. So I guess the thing to think about was what kind of questions do I have to clarify for the best way to clarify how it works. So probably the main question is the shader. And that's the part that is kind of tough because I don't understand very well how Three.js. Uh, I understand it's all those functions, but the problem with the shader to understand on Three.js is that it depends on the data you're gonna receive, which is the same problem that I had like a bunch of times. So because all the functions are based on the parameters, obviously, that they receive, and that you can't know the actual value of the parameter until you run something. Like it's kind of, you have to go with the debugger to see on a practical example what the data would look like and how the sequence of events would happen. And this is kind of the problem. This is why it's hard to know just by looking at the source code. Because then I have to assume what the values are going to be, and then I have to go back and forth between the function calls. And I think it just depends on the specific example. So hopefully this one. So maybe the best thing to do is just try to implement this without using. The thing, so probably the connection between. So I have to understand how does it create the scene and the canvas. Let me go to the example. So it creates this canvas object and creates the renderer. So the connection of the renderer and the scene and the camera. This is something that I don't understand about Raylib as well, that I didn't like very much, which is like the. So I went back to the function of the lookat function for the camera, and then now I understand more how it works, but it's still kind of confusing. But the way that it works pretty much is that you have a point that you want to look, and then you have where the camera position, and then usually it's going to be on the z direction. You take the point and you subtract from the point of the camera, which is just the z direction. With that, you get a forward. You get a forward vector, which is just the distance between them. Then you can multiply the vector by another standard vector that they use, because the cross product of two vectors is the perpendicular vector between them. So you just use a unit vector to get to multiply with the forward vector, and with that you get the right vector. Then once you get those two vectors, you use those twos to get the other one, which I don't remember. Yeah, basically the 3 dimensions. So probably the up vector. Yeah, you multiply the forward with the up, and with the forward with the right, and then you get the up vector. And then based on those 3 vectors, you do some other calculation, which I'm not really sure if it's based on triangles or not. But based on those 3 vectors, you can change the values of the camera so that it looks to the object. But I think the thing that I don't understand very well is like how I'm supposed to use this tree here specifically, like based on that. I think that here there's also something about the ratio, pixel ratio. I can increase the size here, but maybe if I increase once. The problem with increasing the size is that it gets annoying to do anything. So I think here should be 0, 0, 0 in the beginning, and should be minus 3 here. The thing is that OpenGL, the z direction is negative, facing the camera. No, facing the visualization. So facing visualization is negative, and then facing the camera is positive. So if you put a minus value, I think you go like further into the visualization. So you probably have to be a positive one to like get away and then see like the default position of everything. But on the other example, they put -3. So I'm not really sure. It might be negative because there's some operation that inverts the values at some point. I think that the perspective one where they have the -z value for the w, there is something about the inverting the coordinates because the screen is, the y is down. So you have to do some operation that inverts the coordinates for the final screen space, which is also another annoying thing that's kind of confusing. But the main thing is that I'm not really sure how to change the values here in the beginning to make the visualization look at the beginning place, let's say. I think I'm gonna comment this out as well, because I want to see if I can put something on the default place of the camera, or default world position of the camera. But I do remember there's something about, this is the thing, I don't know if I should use the width and height here because I don't remember very well the calculations. I think that it wouldn't make sense, but then I have to do them on the shader. Yeah, I think that's the case. So if I don't do anything on the shader, then I have to use the width and height of the screen that you set up in the beginning here, so that it makes sense and the camera looks at the position, because obviously it's going to be on clip space. So if I want to put these values on clip space, I probably have to, inside of the shader, do the model view projection multiplication. But then that's the thing. Like, should I create the, I guess this is the question that's kind of confusing. Should I create a perspective projection matrix and then pass through the shader? Or should I get from Raylib? Because they probably have to do that for the default values, I think. Let me look into the other code first. At the code from the library. So the thing that I have to clarify is how they are connected. Which is probably going to be, but I don't want to spend a bunch of time going over the code for the screen. That's the problem. The connection between them obviously is going to be the way that they set up the window and the way that they set up the OpenGL in the beginning. So I guess I can copy the code from the example, and then I can just look at the functions that they use there to set everything up. And this is going to be probably the same code, just generating the data for the points. And yeah, so it's pretty much the same thing. So they don't do in clip space the data. So you have to call this normalize, which is a function from the vector tree. Yeah, but this is another problem because the raylib already has a vector3 class or struct, so I'm not going to be able to use the same name. That's the issue. I wonder what happens when there's a situation like this, because I'm not really sure if this is inside of a namespace. So what happens when there's collision of names between two different libraries? Not really sure. I think the one that gets included first is the one that is going to be like the value used. So how can I do this? Maybe I can put everything inside of the namespace and just copy the. So yeah, create a namespace called Threepp, and then I put these classes inside. I think that's probably the best way. Because obviously I don't want to do. Oh, it's already. Hmm. It's probably not. I don't think that's these functions are inside of the. But maybe everything is inside of the Threepp namespace. The thing is that on the example using. So I think everything is inside of the Threepp. It's not a problem. So I'm thinking about this. So another thing, so they have to have shaders here. So I should look into their shaders, try to find the shaders. I think that's the shaders, the names of the variables are going to be the same here because obviously the name of the function. So it makes sense to me that inside of the shader, they're going to use the position variable, normal, and UV, and then they're going to do the calculations. But I'm just curious to see how they're structuring the shaders because maybe it's easier to understand how the shaders work with this library instead of Three.js because they might not have a bunch of includes on the shader. So, I guess I can use ChatGPT as well to figure that out. So how the hashtag include works inside of the shader. I think is this one, yeah. So I want to understand how this works because the thing that I don't get it is how does the linking process works inside of the shader? Because obviously it's going to depend on the compiler and the environment you are using things. So the way that the linking works on C++, you use CMake usually. Then CMake is gonna create the make files. So it creates the object files from each C++ file. Then after that, it's based on the header files and the function declarations, the definitions. It's just gonna create it's kind of like a linked list between the functions and the files, and that's the linking process. And that's how it figures out the path that you put here. So the relative path depends on the way that you include the directories using CMake to make it work. So the thing that I don't understand is like how is it possible to include these values here inside of the shader if the other shaders are done with Three.js code as well. It doesn't make a lot of sense to me. So hopefully this one is easier to understand how that works. But I have to see, they must have shaders here somewhere. My shaders is on renderers. Oh, it doesn't have anything here. Hmm. So maybe they don't create the shaders. shader lib, shader chunk. Weird. So how can I clarify this? Hmm. Oh, maybe it's on the header. Maybe that's why. I still don't understand how this works. Ah, here it is. So it's on data, shaders. Nice. But I don't understand. So it's probably the same pattern. So it uses these two different classes to manage the which shader is going to be used. That's what I assume. But it's kind of hard to understand the connection between them. So I guess I have to see. I have to go from a real example. It's probably the thing that makes the most sense to do. The biggest, the most annoying thing is the beginning here. How do I merge the two? So I guess I'm just gonna write this stuff there, and then in the beginning, and then I'm gonna see how do they set up in the beginning here, the render and the sing. This is kind of the problem, is because the reason why it's kind of difficult is because they're coupled. So the way that visualization is gonna work is gonna depend on the shader code itself. So I can't really like just do a projection matrix and use the camera matrix, which is gonna be the identity matrix in the beginning, and then just pass that to a custom shader to see how the other stuff works. I have to understand how they use the data inside of their shaders to create the visualization. So I have to clarify the whole pipeline, how they structure things, which is going to be the way that I talked about, where both of them, the geometry and the materials are trees. It has class hierarchies that specify how the data is going to be used. And then at some point it creates a mesh between them, which is this thing here. And then this class probably creates the shaders, maybe. So the question is, which class manages the shaders? Or calls the functions to manage the shaders? So it has to be the renderer. So renderer, render. So I'm gonna copy this stuff here. And then I'm gonna go from these functions and try to get to the shaders based on the execution. Let's probably just follow the render function, set the renderer. Then just try to see at what point it calls something related to these files. And let's see what shaders is using by default. It's probably gonna be the same ones, obviously. So just gonna be the mesh basic, I think. So the shaders are related to the mesh classes, not the buffer and the material. The buffer and material is just used to manage the data and the fragments. Like how the variables and the data are gonna work for each visualization. Is mesh basic the one that's is here? Yeah, mesh basic. The one that I was using on the front end. It's the same thing. So I'm gonna ask ChatGPT how this include works on shader. Hopefully ChatGPT is working. I'm gonna be right back. Hey man, thank you. I think that the way that it works is probably it looks through the path that it assumes that the base path is the same directory from the current shader. I think that's how it works. But this is kind of the annoying thing because, and this is probably it, it is the most challenging thing I found so far. But it's kind of like a paradox because it's the biggest challenge is the black boxes. So and that's kind of the problem because it goes like very deep between the discussion of open source versus closed source. And this is another thing that I think about, that like open source is not necessarily bad. It depends on the nature of the open source thing. because the main thing that the way that I think about it is from the first principles in the laws of physics. So it's impossible to have a reality if you don't have boundaries. So there's always a like balance between the two. So the reason why you have walls and the reason why privacy is important is because it's about the balance of stability and creativity. So like things can't be too chaotic and they can't be too stable. So along this gradient, you're gonna have geometry, which is the way that matter is gonna shape on time. And that's the reason why either way it doesn't make sense, because if you fully have everything open source, but this is like kind of the thing, because it depends on the nature of the open source code. Because I think it's not so much about the open source code, it's about what the open source code produces. That's the thing. So if you can have open source code that produces an optimal gradient of privacy and liberty. I'm not really sure how to say that. So like if you're, because it's the same way with the laws of physics. You can use the laws of physics to build walls, or you can use it to build doors and break walls as well. So that's kind of like the thing that makes it difficult about code, because it's not so much about the code, it's about what the code produces. Because if you have fully open source code and the code that produces something that doesn't allow you to have walls and barriers between things, then it becomes too unstable because it's too chaotic. So it's kind of like trying to build a civilization without walls. It doesn't work because it goes fundamentally against the geometrical nature of human beings and of space-time, I think. You need to have boundaries between things. So, and the reason why I'm talking about this is because it's the same from black boxes. So in one way, I understand like you have closed source software, because you want to protect yourself from competition and all this other stuff. So in a way, it's kind of necessary, because otherwise you just get outcompeted. But then the problem with that, and it's not only about that, it's about abstraction as well. So like the creation of geometry in a way is the Occam's razor of a network. So it maximizes energy efficiency by creating abstractions in order based on the synchronicity of a network. That's what programming is, I think, and that's what communication is, language. It's just creating abstractions so you don't have to spend the same amount of energy exchanging information between different nodes on the network. And the symbolic representation of the network is the language of the society, and the programming language, it creates a shared meaning. So the paradox is that the more abstractions you create, the more loss of information you have, because then it opens the space for miscommunication. Because the abstractions you create are going to be necessarily different than someone else, because the region of space-time that creates the symbolic representation for both of you is different, and the symbolic representation is a consequence of the environment, which is going to be parsed through your body, which is the geometry of your neural network. That's going to create the relative abstraction you have, and that's going to become a feedback loop systems that create your identity and generates gravity over time. And that's why I said that is the Maslow hierarchy of needs, which is just a mirror for the reflection of light in space-time. Because in reality, the space doesn't exist. It's all simultaneously created through the paradox of the third eye, I think, which is the singularity point that creates the paradoxical nature of space-time. So that makes it difficult to learn how to code, because, or to understand these things, because you have to trade off the meaning and the accuracy of the information in order to gain abstraction. And then you get these black boxes, and then you don't know like how, because you have to do like kind of a quantum jump between one place to the other. Because the only way for me to be able to fully understand this is if I go under the source code, and then because of the nature of the thing, I might not have access to the source codes because it's going to be a binary. So you lose the bridge when the language you use to create the connection between different points is different from the language that a network uses to have synchronicity with itself. And I think that that's something that creates boundaries between people as well. So if you have two different cultures that speak two different languages, there's inevitably there's going to be boundaries between them, because you're passing information from one point to the other using a different language. So that point in space gets lost in translation. But I think that's a necessary part of reality. It's not that if you have only one language, I think it's impossible to have only one language because that goes against the nature of space-time. So it's kind of like collapsing everything. It's the same problem with communism that people don't, I think they don't understand, is that it's impossible to have something fully decentralized because if that was the case, space-time wouldn't be the way that it is. It has to be a hierarchy to some degree because both sides of the perspectives are codependent on each other. So you can only have decentralization in relationship to centralization. And I think it's the same thing with language. So that's the thing. I'm gonna have to. I think that the way to. I'm not really sure what's the way to solve this, but one way to go about it, which is the way that I'm going about it now, is just to do tests. So I think that's the best way, probably. Like something, but this is the thing that is kind of annoying because then you lose a lot of energy, like doing things that are not effective because you have to test a bunch of things. So here, for example, the way that I'm thinking about solving this is obviously just I can create a basic shader and then I can put these shaders here, and then based on that, I'm gonna see I can test different paths here, and I can just simplify the shader so that includes only one thing, and then based on that, I'm gonna be able to know if it works or not, and how does the path here is related to the one shader to the other. But I don't want to waste my time doing that. That's the problem. So the main fundamental question here, I think, is like how do you solve this paradox? How do you make it so that you can, without having to review all the information, how do you, and I think that's probably the reason why it's going to be crypto, the answer, I think. So zero knowledge proofs, because that's something that I've seen in crypto as well. Data availability sampling, which is just a technique that allows you to expose a certain part of the information. And then based on the polynomials, you can verify based on public and private keys. And I think it's elliptic curve cryptography. You can know whether or not the information is correct without knowing too much about the information. So I think that's probably the key to solve this issue. It's something related to using data in cryptography to create some visualization or some shared language that allows you to understand how the thing works without knowing the specifics of it. How to learn C if I have basic JS, I want to know. I don't know how to answer this question. I think it really depends on like who you are and what you're good at and your level of understanding of a bunch of other things. So like usually the approach that is going to be best is going to be the middle way of some polarity. So like most people, because society works on a Pareto distribution, which is 80-20 rule, 80% of the people are going to lean more towards trying to be energy efficient, which means that they're going to create a bunch of stories that rationalize their behavior so that they don't have to get out of their comfort zone and they don't have to grow. So that's why most people get into tutorial hell, because it's a story your body creates to your mind in order to justify your current position. So you don't have to take risk and you don't have to spend more energy thinking about the nature of your existence, because you can go crazy if you do that. So you have to be mindful of that, and then you have to try to strike the balance, because the other way is the way that obviously everyone talks about it, that works the best, is just building things. The problem with that is that if you try to build something right away, you're gonna get discouraged because you don't know much about it. And this is kind of like the paradox I'm struggling with as well. It's like, how do you know what's the best way to do things if you don't know what to do in the first place? So I think that the best way to solve this is by creating a funnel of information. So you watch a bunch of videos at a very fast speed, and you try to go wide in the information. So get a bunch of different sources from videos explaining the same thing, and you don't need to focus on understanding every little nuance. You just go very fast and try to go wide. Then after you do that, you have some general idea of how everything's connected. Then you try to build something. And then what you're going to notice when you try to build is that you're going to have all these natural questions based on the way that you want to do things. So for example, one thing that I was trying to do, and probably that I'm going to look it up later, is that I was thinking about creating a function, and then I want to return multiple values from a function. So that's the natural question that comes up. So how do I return multiple values from a function? So one way that I thought about it was by using structs. I don't know if that's the best way or not. So probably what I'm going to do is just watch a bunch of videos and then try to get an idea, and then I go back to try to build. Because if you keep going through this process, then eventually, like you're gonna integrate the stuff. Because your body is like a hardware. That's the best way to think about it. So your body, your synapses, your connections, they are going to store information over the environment. So whatever, and that's why attention is important, because whatever you put your attention on is going to become your body. And then all the stuff you know and all the stuff you think is yourself is just the gravity inside of your body that's of the information that you absorbed on space-time. And that's going to become a cycle. That's your identity. So the way that you correct that is with awareness. You have to be mindful of the connection between your actions and how they translate into the environment. And then you have to reflect on the nature of reality, so philosophy. Because that's the only way you're going to be able to recalibrate your actions, so you can get closer to creating something that is in alignment with whatever you think is best, which nobody knows, because I think is irreducible. So it's the final answer, I think, is a paradox, but I'm not 100% sure. So the other thing that I can do, it probably is worth to do this, I think. So I can go over shader by shader and just see, because I assume that on these other shaders there are going to be some code. It's not going to be all includes. So this is the main one. It's kind of like creating a header file in C where you put everything. And then it's kind of creating an interface between your library and everything you use. So you create a header library just to put all the other headers on. I assume that this is what's happening here. And then on these other files, they're going to be the actual code that is used on the shader. So I can't go one by one and see. I'm actually curious about that, but I think I'm going to go over the main setup first to try to understand how everything works. After I go through the main setup, and I'm going to try to see if I can find the bridge between the renderer and the shader creation. The classes that actually create the functions that are going to run, they're going to select the shaders and run them. Once I understand that, then I think I'm going to go over the source code for the shaders to try to understand how they're doing calculations inside of the shader to change the visualization. I think that's probably the best path. We should try to copy as many classes as I can, but I'm going to have to, I think probably is better to try to change the shader code. So, because there's a high chance that I can like remove a bunch of stuff that I'm not going to use, because they build the library for more generic purposes. And I think that this is a good idea, because even though I'm going to have to maintain the new shader code, it is very possible that along the way, as I find more stuff, or I think more about what I'm doing, I'm probably gonna want to create different styles of visualization that are not just a graph, using textures and everything like that. So gaining a lot more power by understanding how the textures and shader works. So I don't think that's something I can avoid. So I'm probably gonna have to. I think that's probably the best way. So maybe I create another shader and then I just replace the include function, include code in the main shader, and then I just try to analyze how all the code works, and then I just try to remove as many things as possible and just leave exactly what I think I'm gonna need. I think that's probably the best thing to do. The other main thing that I have to understand is at what point exactly they are passing the data. I think that's the big thing, because it's really like the understanding if they're passing like model view projection matrices and how they are doing that, because that's obviously the other component. So if I change the shaders, I'm gonna have to change the other classes, I think. in relationship to what they're gonna pass to the shader. And the problem is I have to include, but I didn't install. I think I'm just gonna, okay, fine. I was gonna say that probably gonna try to look into manually, see where the functions are at. So there's a unique pointer. I think the name of this is list initialization. So the way that it works, you just put 2 dots here and then you initialize all the variables, I think, with these values here. So in this case, just initializing the viewport with the values that pass through the constructor. Or maybe this is private. No, it's so initialize the size based on this. There's a struct that we pass when you initialize the class, the struct. Because the structs are classes. And structs have everything public by default, and classes have everything private. So that's the main difference between them. So you have this variable. So here is just a convenient way to initialize all the attributes of the class based on this stuff here. Initialize the size, the struct of the size based on the variable there, and then initialize the viewport with these values and everything else. And this struct is apparently used to manage the implementation. What is? It's just a unique pointer. I think I saw on this function. Yeah. So this one probably holds the states of the visualization. Holds the values of the camera, the projection, stuff like that. And that's the stuff that is gonna render. So on Three.js, the way that they do it, as far as I understand now, I'm not really 100% sure. I think they give you the option of creating the scene graph, which is just a tree that connects different models to each other, so that once you update one of them, it updates the others. But I don't think that all of them are this. I think that the way they recommend you to do it is first to create the scene, which is just going to be a matrix as well. And the matrix of the scene is going to be the one that connects everything together. So the scene is going to be the parent, and everything else is going to be a child. And then once you update an object, there's a function that automatically updates the scene as well, which is a recursive function that is just traversing the tree and doing this multiplication in the matrix to update whatever math you did to update the values of the object. So I think that this is the function that does that. The update matrix just does the matrix multiplication. And then there is other functions on, I think it's on this class. This is the base class, I think, from the mesh. So this is the base. So it's the same thing for all of them. They all create the abstract class at the base, and then there's other classes that are childs that use the template class. So this one is the parent for the mesh, the base class for the mesh, which is going to be the final thing that you use on to create the shader. So if I remember correctly, this class has one recursive function that updates everything. Yes, it is this one. So it's just looping over the children of this this object, and then it's calling the same function to update all the matrices. And I assume that are going to be model matrices that it updates, because the model matrix holds the state for the object. And updates them by multiplying. The thing that I'm trying to understand is at what points do they call the shader? It's probably on this one. I think from what I remember from 3JS, this is the function that renders objects, and then it's going to be inside of this function that you call some other functions that are going to call the draw calls from the shader. But maybe it's on the initialization that's the shader, because I think it's on the initialization of this class. So this is how it works on 3JS, as far as I remember. When you initialize the render class on 3JS, in the beginning of the constructor is going to initialize the other classes that handle everything. So I think once you initialize the classes are gonna, it's kind of like calling the functions on OpenGL in the beginning, just set up all the buffers in the beginning. So yeah, that's probably what happens. So on the construction of the class, you call the functions that are gonna set up the buffer, the structure of the buffers, which is the vertex array buffer, the vertex array objects that are gonna be used, probably, which are probably generic. But the thing is that it depends on the data that's gonna be passed. That's the problem. So maybe it doesn't set everything up, but sets up just the beginning. And then once it gets time to draw stuff, then it's gonna call other functions that are gonna check how you should use the data. No, like it's gonna pass the data, and then it's gonna check how you should use that data on the buffers should draw. And that's probably when it selects the shader as well. But I'm not really sure. But I'm pretty sure there's only a few classes related to the shader construction or the program. It's here. I think yeah, this is one of them, and then there's another one. I think is inside of this one, the cache. It seems like this is the only class that is related to creating the programs. And then inside of this, there's another. It is a function, and then this has this probably caches the shaders that are being used. So here, this is the code. So at some point, it probably inside of the render loop, it probably calls this function, and then based on the map there. So this is a material type, and then you specify this on the material class. So there's all these types here, and then the type's gonna be equal to the name, and then based on the name, it's gonna get from this file, I think. Yeah, shader lib, which is this file here that has all the. So I have to see where can I find this file. So it's probably the render. It has to be the same thing because I don't see why it wouldn't be. It would be different. I'm gonna look into the other function first. This one. So it keeps track of everything that it's gonna render on this render list probably. Then the render item has object and the geometry. Object, geometry, and material. I don't understand. Oh, it's because it's this one. So it loops over them, then calls this function. And this is the one that I was looking at the last time, I think, or a couple of days ago. So inside of this function is probably the one that manages the buffer. Set program. It's kind of annoying, to be honest. Even though I think I can see the path clearly now of how to do everything, I want to avoid having to think too much on. Because the biggest problem for me is the C++ parts. I'm trying to think about what is the way that I can structure everything with the least amounts of risk of doing something related to C++, about memory and stuff like that that is going to give me a bug that I'm going to have to spend hours or days trying to figure out. So in one way, in my mind right now, I'm thinking about, like, I wonder if it's possible for me to just remove all this complexity, because like probably most of the stuff inside of the classes I'm not going to use very as well. So but it probably is the best way that they did it. Like the structure I think is good. So like, having the object 3D as the abstract syntax class and then everything else. So maybe the classes are good. So I should probably try to copy all the classes. I'm gonna write. Maybe I should do another thing here for the steps on this one, so I can organize my mind. I'm thinking about like first get all the classes for that create the hierarchy of the tree of the geometry, material, and the mesh. Then after I do that, obviously I think I'm gonna get rid of all the rendering things. But maybe I don't know. Maybe it's a good idea actually to get everything though. So maybe I should just incorporate the library. That's the easiest thing. Like just put on CMake to add the directory, then just use the library directly without changing anything. Because the thing is, the renderer, they already set up everything to manage the scene state. But then the question is like, is it worth it to get rid of Raylib and just do it with 3D CPP? Maybe what I should do is just create a project only with 3D CPP or 3DPP, and then just try to render stuff from that project. But the problem is that I'm not gonna have the GUI elements now. That's the issue. So I think I have to get, maybe I don't have to get rid of the renderer. I just change the functions so that instead of them initializing the window, they use the window that was initialized by Raylib. That's probably the best thing to do. So I forget about using the shaders from, or the shader struct from Raylib, and then just use all the functions from Threepp, and then I just modify them to work with the Raylib camera and the Raylib window. I think that's probably the best thing to do. Because the renderer class is going to have a bunch of functionality that's probably good to have to structure the scene. But the biggest issue with that approach is that I'm going to have to spend a bunch of time thinking about it, how everything is connected. But maybe that's the best way. Yeah, I think that's probably the best. And the main question is whether or not I'm gonna be putting a bunch of unnecessary complexity. That's the thing that I wanna avoid, obviously. So ideally, I would be able to simplify everything. But then if I try to do that, it's gonna be a bunch of time as well. Hmm. I think the best way to do. So I'm probably gonna have to do this. I'm just gonna have to change all these functions. So what I'm gonna do is just try to add the 3PP to the project using CMake. Then just change the functions to so that they use the Raylib camera instead of creating its own camera here. This is kind of the problem though because they are coupled together. But I think I don't have to use the Raylib camera though. That's the thing. So the main thing is probably but maybe there isn't a problem. It's just the window. Actually, I don't think I need to change anything because I don't think that the 3PP library creates the window. It's just responsible for rendering stuff. And there isn't anything about windows here. Maybe the canvas. So I have to understand how the canvas work. I think that the only thing that I need to change is the window, the relationship between all these other functions and the window. And then I can use everything from this library. That's probably the best thing to do because then I don't have to spend a bunch of time thinking about how to structure everything, and then I can just get to the point for the stuff that I actually want to do. The maybe I can run experiments with the shaders as well. So the only thing that I have to do is change the code that selects the shaders if I wanna, or change the shaders themselves. But first I have to see if I'm gonna be able to add this with CMake, I think. I need to see, I need to get I'm gonna look into the canvas first, canvas code. And so in C++ you can override the different constructor. You can create a bunch of different constructors, and they're going to be used for different purposes. So as far as I remember, when now I don't know very well, but I know that there are situations where you have one constructor for when you don't specify anything, when you initialize a class, and other constructors when you specify certain things. So here, for example, it's initializing with this demo, which is probably a pointer to a character. So it's going to utilize the whatever constructor accepts that, which probably is this one. And then if you don't use that, then it uses the other constructors. So the way that we resolves, I think, is based on the specification and detail. So the closer it is to what you actually said, is gonna try to do that. So if you can't find a constructor that has that specific thing, then it's gonna look for more generic ones. So ones that use templates, for example. So I guess this one you can either initialize based on a name, or you can pass parameters, which are probably stuff related to the camera or the size of the window and aliasing. So maybe one thing that I can do is just pass. I can initialize the Raylib window and then just pass the parameters to this one based on the Raylib window. And that's probably the best thing to do. So it maps a string and a parameter value. Just an object. And then it's looping over the object, checking to see. So the keys are these ones. So I imagine that the way that I can do this is just specifying this with a value. So I initialize Raylib, then I specify this and map the strings to values of the Raylib window. And then I call the whatever function, I call the canvas with the passing this struct. I think that's how you do it. And you pass as a reference. Hmm. So probably what I'm going to do is just try to compile by putting this, adding subdirectory on CMake. And I think that it passes the canvas to the renderer, canvas size. Just gonna return the window size. So just passing this to the renderer. So if I remember correctly, I don't understand very well how it works, but you have move semantics on C++, and you have the copy operator, or not sure, I don't know if it's a copy operator, but basically when you do an assignment, what C++ does is copy the class. So when you put only 1%, I think that's, you can specify what functionality is gonna happen when you assign the class to another variable. And here I think that it's just deleting this constructor, so you're not able to use that. And then when you put 2%, instead of copying the class, it just moves the ownership of the class to another variable. So it's just like it's kind of like you're moving the pointer from one variable to the other when you use the to %. So I think that's what they're doing here is just deleting this functionality, so you're not able to reassign the class, and you're not able to move the ownership of the class. But I'm not 100% sure. And then this is just operator overload, which overloads the. So it's probably what they're doing here. So in order to avoid people from creating an instance of the class and then assigning that instance to another variable. So, but all of them except, oh no, this one. So it's probably it is using this constructor when it passes the canvas size to this thing here. And I guess it doesn't matter that it doesn't pass this because it's going to be by default an empty object. So this is initialization here is using this constructor here. And then it's just deleting the possibility of the other ones. Yeah. And then this one, it just initializes this struct, which is going to manage the state probably of this class with this unique pointer to this, a pointer to this class, or the instance of this class, the window size and the parameters. It's just a unique pointer of the struct. So it has the window size here, and then probably has the other stuff somewhere. The parameters. Yeah, here. So it's using parameters here. So let me try to add this on CMake. See if they have anything that's like this is another annoying part. It's probably the most annoying part of C++ and C. Like figuring out what is the best way to set things up with CMake. Because usually the libraries have dependencies and then it becomes annoying. So obviously the easiest thing to do is to, what I'm gonna try is to do the easiest thing possible. Just add subdirectory. So yeah, that's probably the best idea. So right. So I'm gonna have to create. So maybe I'm gonna break this down. So I have to create this thing first, and then pass. Yeah, because this is probably gonna contain the whatever I wanna. Yeah, the size here. So I have to pass size and then pass something to the value. And the question is what kind of type, like how I'm gonna do this. Let me remember the raylib thing. Not really sure though if that's gonna work. Hmm. I think I'm contemplating now is whether or not this is gonna work because obviously this I have to look into this thing first, I think, before I do anything. Because I have to understand how the window is gonna be related to whatever you have to do here. Because obviously all these functions are gonna be related to the thing. So like if I do it the way that I'm thinking about doing, then obviously I'm not gonna use any of these functions here. But then I wonder if that's gonna be bad because I'm gonna probably have to connect them in some way. Like this for example, I'm gonna have to use from raylib. Then like it's kind of unclear how they're gonna be related. The way that it would work if I try to do like this is if I leave everything to the render from the Threepp library and don't use the raylib to do anything related to the visualization. Just use raylib to, but that doesn't sound very good. Probably the best thing to do is to choose another library, to be honest. So I have to understand either GFW or IMGUI, EMGUI. I'm starting to think that's better because from the videos I've watched as well, it seems that the other GUI libraries they have more advanced features. So I think that's probably the best path to go with. The main reason for using raylib is just to create a visualization. I'm not using raylib for the GUI components. And it seems like it is better to just use this library instead to do the visualization because it has exactly what I want. So it would make more sense. But then obviously the issue is going to be that I'm going to have to, the most annoying part is going to be the CMake. So I probably, I think I'm going to do this. So I remember, the problem is that I remember trying to create a project with IMGUI and it was very annoying because of CMake. But it's probably the best thing to try. And I'm not really sure if they use GLFW for the creating the window. Probably the best thing to do. So yeah, that's what I'm gonna do. I'm gonna create another project, and I'm going to try to create with IMGUI and this project here. Yeah, and then I don't use raylib. That's probably the best thing to do. I wonder if they have something though. as some documentation or something that makes it easier to integrate the two. It's not gonna be just gonna be the same. Maybe if they have a Discord or something, just ask there. Because obviously I wanna just like avoid as much as possible spend a bunch of time figuring out. If I can, then obviously I'm gonna figure out, but it would be much easier if I can just get an example and then do it from the example. If I can't do that, then obviously the way that I'm gonna do it is just the way that I was talking about, but I'm gonna use IMGUI instead of Raylib because I think it's better. For at least from what I know right now, obviously my opinion can change, but from the little experience or the little knowledge I have, I think that the benefit of Raylib is that it's very easy to start and that you can do both the visualization and the GUI elements. So I think the main benefits that is easy to start with the visualizations. But then if I don't think it's worth it, like the time invested is not going to be worth it to just merge Raylib with this one. And this one has a lot more code that is going to be harder to recreate if I want to use Raylib. So because the strong part of Raylib is not the GUI elements, I think that it doesn't make sense to try to integrate Raylib with this one. It's much better to reuse all this code that is more complex and harder to replace than Raylib, and then just learn the library that they recommend here, which is IMGUI, because this library is going to be more powerful to create the GUI elements as well. But then the downside is that I'm going to have to spend a bunch of time figuring out the CMake files. But I think that's probably the right direction. So I'm going to create another project and I'm going to and once I figure this out, create window using GUI, then figure out how to pass the window. So probably it's easier to integrate with this one because they use the same type for the window, I assume. Is this struct here that Raylib uses, I think. So I would have, if I use Raylib, I will have to initialize the thing. Actually, I was gonna see if the function returns something. But I guess I can just access this directly because it's gonna be a global object on Raylib. So I can just call init window, then like create a variable that points to this this struct here inside of this other struct. Then pass the values of these variables as in the other struct, which is the parameters struct from the other library. And that's how I would connect the two. So I think the name of this pattern is dependency injection. I'm not really sure though. So I would initialize based on that, and then pass the values as parameters. I think that would work, and then I wouldn't use any functions from Raylib to render anything. I would just use these classes here to render and manage stuff. But I think that doesn't make sense. So what makes more sense is just to figure out IMGUI. I guess I can see. It doesn't return anything. So I'll have to access the structs after. Hmm. I think what I'm gonna do is just stop here and I'm gonna watch a bunch of videos on AIMGUI. I'm gonna try to see if I can find maybe a Discord or someplace that I can find an example that uses AIMGUI. Maybe these ones, because you can click. Maybe in one of the examples that they show, there is an integration with AIMGUI. That's probably the best thing to do. Try to find an example that uses both of them, and then if I can't find, and then I'm just gonna learn AIMGUI. Then figure out how to initialize the window, and then it's probably the same thing to merge the two. Create the window separately, and then you just pass as you initialize the canvas object for this library. You just pass the parameters from the other one. But I'm gonna do this stuff off stream, so I'm gonna stop here. So the first thing that I'm gonna do is just this thing here. Just gonna set up another project and probably gonna spend a bunch of time trying to figure out how to make the two libraries work with CMake. Then after I do that, I'm just gonna try to see if I can find a simple example on Threepp. If I can't find, then just initialize an example AIMGUI, and then try to integrate them with the code directly. Then after I integrate, I can go back to studying the source codes. And probably what I'm gonna do is just try to change, once I have everything set up and I have a simple visualization that uses the same geometries I was using, I think it might be worth it to try to see if I can simplify the classes or simplify the shaders, or maybe use other shaders. But maybe it's not worth it to do that. Maybe it's just worth it to just try to merge the graph with this library already, and then just, I think that's probably the best thing to do. If I manage to do this stuff, because then the most important thing is the stuff that I'm gonna do later, which is just to get the data and then visualize it. So it's probably a waste of time to try to optimize here. It's probably better to make this class work with the AIMGUI than just once I make that work, I just merge that with the creation of the graph from the other project, and then I create another project to put everything like the final thing. And then from that point, I just focus on that project, because then it's gonna be about getting the data. So the main thing that I want to understand as well, that I'm gonna have to spend a bunch of time studying, is the events. Because I'm gonna have, so how to integrate the events from the Threepp with the AIMGUI things, because I'm gonna have to connect them both. So I'm probably not gonna stream for some days, because, or maybe I'll stream tomorrow just studying the source code. I think I'm gonna stream just studying the source code, and then after I do that, I'm gonna watch a bunch of videos on AIMGUI and try to find resources on Threepp to, like a simple example. So I'm gonna stop here, probably gonna come back, look, if not tomorrow or a few days from now. So see you then.